So for our final lesson in this unit, we are going to look at the electromagnetic spectrum. And you're probably like, what is that? All the electromagnetic spectrum is how we see light and color um, from these atoms. So you probably think, oh, well, I see color because I'm wearing a blue shirt. Well, no, that more has to do with the fact that your shirt is made up of atoms, and those atoms are moving electrons around. And when those electrons move, they produce a light, and you see that reflected back to you in the color blue. So that's why it's important. So all the light and color you see have to do that. And we're actually going to look at things that are even bigger than just light. We're going to look at things like radiation and radio waves and things like that. So waves, everything is in waves. That's how we see stuff, okay? And so the three things that we need to understand, and you're going to put this on your paper at the top, is that wavelength, frequency, and energy are all related. So at the top of your paper, you want to write that high frequency equals high energy, which equals shorter wavelength. So and then low frequency equals low energy equals longer wavelength. So think about this as running around the track. Okay. If I run faster, I'm going to have a shorter time, right? So the faster my legs move, right? The faster my legs move, the more energy I'm going to have to expend to do that. But the shorter it is, the shorter the amount of time it is to me walk or run around the lap or the track one time. Consequently, if I go slower, so let's say I walk it, okay, I'm gonna not use as much energy, okay, you don't feel as winded walking as you do running, and then but it's gonna take a longer time, okay. So that's a great way to visualize. Okay, so visualize yourself doing a track. The faster you go, the shorter your time, but the more energy is required. Okay, the same thing. Lower you go, the lower energy you require, but the longer it takes to get there. All of this has to do with the spectrum, and that's going to show you how our light is emitted. So depending on what's happening, okay, you're going to either see a continuous spectrum, which is mostly when light, everything's kind of moving at the same time. There's going to be things that are being absorbed, and there's things going to be being emitted. Okay, and then if you have emission, okay, emission means that you release energy, and that's this one right here. So when your electron releases energy, and it releases energy when it jumps down a orbital ring. Okay, so jumps down a ring. Okay, so if you go from 5 to 3, you're going to emit light. Okay, remember that's from the Bohr model. Emission is being released. You are going to have a quick burst of light. Okay, a quick burst of light. Now, if you're taking in energy, it requires some more time to take it in. Okay, your light is going to be there for a while. Okay, and you can see that, and there's going to be little breaks when you finally get settled. Okay, so absorption spectrum, electrons move from a lower energy level to a higher one. Okay, so we're going to go up. Okay, absorption's going up. It requires energy to do so. Remember Hog Hotel? It took energy for them to go to the next level. That's why they didn't want to do it. So you absorb energy in the continuous spectrum, producing dark light or dark lines. Emission, electrons move from a higher level to a lower level. Okay, you're going to release that energy. That's a quick little burst. Emitting energy at a specific wavelength, you're going to have one line on a black background. So what I want you to do on the where it says continuous, emission, and absorption spectrum is I want you to color those on that slide before. Now, why is this important? Well, we got to think of light not as just a wave, but also as a particle, because remember, a electron is just a subatomic particle. And so what the theory is that light acts like a wave, and it also acts like a particle. So a wave is going to hit everything at once, right? You take in color with both your eyes, you see it all around. But really what's happening is you're seeing one electron being bounced off of something or being released. Okay, so it's going in a straight line and ending in one point. The video that's below this one is a great resource to kind of explain it a little better in picture form. So finally, what I want you to do is pull out your little blue Bible, and you will see on the back, on page 8, you have a picture very similar to this. Okay, so on this picture, what you have is called the Bohr model of the hydrogen atom. And what it is just we have our rings. So here's our nucleus. Here is our first energy level. Here's our second, third, fourth, all the way to 6. Okay, and really we could go to 7 energy levels. And in this, the electron is going to move. That's what these red dots are. So they're going to move from one ring to another ring. Okay, all of the electrons that move from their outer rings to ring 1 will release UV light, and that's down here. They will release it at different wavelengths. That's what these numbers are. Okay, and what you can do is you can look and see by following where your dot is, just follow the line down. So for instance, this dot, which is on ring 3, has an emission of 103. Okay, and this is in nanometers. Okay. Okay. If you look here, all of these dots will end at the ring 2, and they're going to emit visible light. Now, visible light comes in colors. So I want you to go to the bottom of page 8, and you'll see that there's different colors. Okay, there's red, orange, green, blue, violet, yellow. Okay, I did not put those in order. But what you're going to do is you're going to take the number you see. So for instance, this dot right here on level 4 has a reading of 486. All I want you to do is move the decimal at the end of 486 between the 4 and the 8 and find where that number falls on your little sheet. And it should fall somewhere between, I think, around blue, if I'm correct. I don't have mine in front of me. But you're just following where it's going to fall on there. Don't worry about the times 10. Just move your decimal point here between your first and second digit. And that's going to help you determine what kind of light you have, what color it is. And then finally here, anything going down to 3 is going to give off infrared. The other thing on that document is how strong the wavelengths are, the different ones. And you'll see that on Monday when you do your lab, unless you get started early, you are going to see that radio waves are long, they don't have a ton of energy, versus gamma rays, which are full of energy, really short wavelengths, and they rank downwards. So finally, on your sheet where it has the lines N7 and 6 and 5, 4, 3, 2, 1, you're going to draw lines. All we're drawing is the same thing as the Bohr model. It's just a different way to see it. So from N7 down to N1 and anything below that. So anything going to 1 is going to release UV light. Anything down down to 2 and anything down to 3. So draw your lines. And like I said, anything down to 1 is going to release UV. Anything down to 2 is going to release visible light. And anything down to 3 will release infrared or IR light or energy or radiation. Those are all ways you can see it. So if it asks you from the 6th, from energy level 6 to energy level 1, you release IR light. If I was going from 5 to 2, I would release visible light. If I was going from 7 to 3, I would release IR. So you're just looking at your number and seeing where you're ending at. Your ending point is going to help you determine. So 1 is UV, 2 is visible light, 3 is IR. So let's practice really quickly. So if I go from 5 to 3, if I look back up here, 5 to 3, my ending at 3 gives me infrared. If I'm going from 3 to 2, I'm going to release visible light, but I got to figure out which one that is. So So I'm going to go here. Okay, visible light is, sorry, let me go back. So again, if I'm going from 3 to 2, I'm going to look here. I'm going to find 3. I'm going to find the arrow that goes to 2. I'm going to follow it down. It's 4, 3, 4. So I'm going to find what color that is, and that should be violet. Okay, so violet, not ultraviolet, just violet. All right, and then finally, if I'm moving up energy levels, I'm going to absorb energy. So going from 3 to 6, again, I absorb. If I go down, so from 5 to 2, I'm going down, I'm going to release energy. So those are great ways. Don't worry about putting it on the bottom of your page 34. That's just something else. I just want you to practice that. All right, so go ahead and finish up your lesson and get ready for the lab.